Hi, this is Sinija. I'm going to explain my second question of my midterm exam. Yeah, and the second question asked is about like bubble sort algorithm. First, what is bubble sort? Bubble sort is nothing but like it is a simple sorting algorithm that repeatedly steps with the list. That means like it checks every adjacent element to it and it swaps them if that is in wrong order. If it is like in descending order, so I will check for the larger element to be swapped first. Then the smaller element will be going on checking with the every element in the list and it goes to the last place. Yeah, that is what a bubble sort is. And it also asking about like what are the key features about that. Key features are like comparison and swapping. This like algorithm compares each pair of adjacent elements and swaps if they're in the like I certainly said in the wrong order. Then also we have multiple passes. It is like here multiple passes are required because the list contains certain elements. So we need to check with the every element and if it is small, then we need to sort it to the ending. So it should be having multiple passes. And also we have one more which is like termination. This algorithm stops whenever there is like if it has no swaps and the order is completed to the descending order. That means like the list is sorted so that this algorithm terminates. So yeah, this is what. So now we need to do the descending order. Descending order of this set one. So if I take this, my set. So if I do first pass, these are my elements generally. So in next pass, I get now 54 and 32 I should compare. So 54 is larger, so no need of swapping. And if I say 39 1, 39 is larger, so no need to swap. If I say 199, so 9 comes here and 1 comes here. And if I want to show you, so this one comes here. So when I compare 19103, 1 comes again here. So if I compare 1929, again the 1 comes here. And if I compare like 1916, again 1 comes here. If I compare 1992, 1 is smaller, so again this 1 comes here. So this is how 1 came here. And again, if I do other pass, so in this, again, I will take this entire list. And if I compare 59, 32, 54 is larger. If I compare 39, 9, 13 is larger, so no problem. But if I compare 99, 103, this 9 comes here because 9 is smaller than 103. And if I compare 99, 29, this 9 is smaller than 29, so 9 comes here. And if I compare 9 and 16, this is smaller, so it comes here. And if I compare, it comes here. If I compare 9 and 18, 98 is larger, so it comes here. And if I compare, yeah, if I compare 991, 9 is larger, so it stays here. So in the same way, when I do pass 4, it is also the same way. So if I compare this to this larger number, if I compare 39, 103, so here 103 is larger one, 13 is the smaller one. So 13 comes here. And if I compare 39, 29, 13 is smaller. So again, this comes here. Again, if I compare 13 and 16, 16 is larger. So it comes here. Where 13 and 98. Again, like 13 is smaller than 98. So it comes here. Yeah, and 39 is larger, and from 991, 9 is larger. So this is how. And if I comes to pass 5, yeah, when I compare 54 and 103, here 103 is larger than 54. So 54 comes here. And if I compare 51 and 54 is larger, so it's like no problem. And when I compare 29 and 16, 29 is larger, so that's fine. And if I compare 16 and 98, 16 is smaller one. So 16 comes here. Actually, 354. Yeah, 29 and 16. 29 is larger. If you compare 69, 19, 16 is smaller, so it comes here. And if you compare 69, 13 or 16, yeah, these are like in the correct way. We compare, if I check this is larger. Among these two, this is larger, but among these two, 29 is smaller than 98, so it comes here. And if I check 29 and 16, 29 is larger, and 16 and 13, yeah, 16 is larger. But from 16 and 13, yeah, this is the way. So this is swapped. So this is the descending order, like, oh, no, again, one more, I missed it. So I do once again. So here 98 is larger than 54, so 54 comes here. Yeah, I think this is the correct way, like 103, 98, 54, 29, 60, 30. Yeah, okay, this is the descending order. So by using bubble sort, we have sorted the order in the descending order. So this is the sorted list. So and it is also asked like, or like in such a way it touches time complexity and for this one. So as in set 2, actually this is already in a sorted way, in a descending order from large to small. So no need of doing anything. If we try to swap also, if we compare 90 and 45, no swap, and 45, 23, no swap. In that way, there will be no swaps happening. So, and the flag becomes here 0, false that is. So there are no swaps and the algorithm ends and terminates at the first swap itself because there are no swaps. So there are no swap, the time complexity becomes big of n. Yeah, that's it. This is my explanation for the second question.